All right, let's give this a shot. So, welcome everybody. Hope you all had a great Thanksgiving. Hopefully, it was relaxing, and I'm sure there's lots of things to be thankful for. So, let's kick into commercial duct testing and go through some options. Our goal today is to focus on just bottom line as to what's commercial duct testing and what Retrotech has done to kind of change that industry, and what's the difference between residential and commercial duct testing, because there is actually uh, a shocking world of difference. So it's not just a matter of still putting up a tester and finding the results and seeing how they comply. So here we go. So you should be able to hear me because I've confirmed that people can see my screen, and that there is sound coming out. So we welcome everybody. For those of you that may be new to a Retrotech webinar, I just want to make sure that you know to please use the questions area, because our goal is to kind of get some feedback going, learn more about what people are doing, what kind of experience they have, if they're doing commercial, only residential, how'd you find out about us, that kind of stuff. So also, we want to make sure you know that in your handout section in your control panel, there actually are several PDFs to download that give you some information about the duct tester manuals and a comparison guide and a sample of the a report from the software. So for those of you that are looking for CEUs from BPI, Internachi is a self-reporting process, but you must pay attention to the webinar. As I've told people, if you do any kind of webinar, if you want CEUs, just open up your phone or a tablet or another computer and kick it on and use that, and leave it alone if you want to do the multitasking thing. So this needs to be your main screen for the majority of the time that the webinar is actually happening in order to get your CEUs. So if you fail to give us that information for BPI, give us your full name, email address, and BPI member ID in the questions menu, and we'll make sure you get your CEUs. But don't be the sleepy cat who really wasn't paying attention or didn't make this active screen, because you'll not get your CEUs, and you'll ask us why, and we'll have to tell you that you were not paying attention visually to the actual slideshow. It was not active. Okay, so let's see if I can't get some people to give me some feedback here. We got a great turnout today, and I'm looking for your kind of experience. Like, I do commercial projects, I do both, I do residential. How long have you been in the industry? Do you own one of the commercial duct testers from Retrotech? Just trying to get a feel for the audience that's out there. I have no idea what we're talking about today. Whatever you could do to give me an idea about who you are and why you're here helps me a lot, so I appreciate that. So I do want to do a shout out to my buddy Brian Orr. Many of you may have found this link through Brian. Brian is I've only known him a short amount of time, but I consider him to be a great friend. So he's an awesome family man. He owns Kalos Services, which is HVAC, and R, which is refrigeration, down in Orlando. And if you're really looking for some great education and continued education, the HVAC school is something that he designed to help his own technicians, and realize that there's lots of technicians out there who wanted more information. So he's got a phenomenal podcast. And if you're looking for great information from residential line sets, refrigeration, whatever it is, he's actually the number one person to go to for this kind of information. So I encourage you to reach out to HVAC School and support what Brian's doing, because it's actually going to be a major support in changing how people perform service calls. So thanks a lot, Brian. So a couple quick announcements. There's always some things. Retrotech promotes this and supports this as a webinar. Clearly, it's their products, but we want to make sure we allow people to understand. So today's the gift giving day. So maybe this is the gift from Retrotech. So you can trade in your existing DG700 gauge, all right, and with that, with a little bit of money, you can get a brand new DM32 with Wi-Fi and the adapter that allows you to control your existing Energy Conservatory fans, whether it's Duct Tester, Duct Blaster, or their blower door. So this is a great opportunity for you to look into trading up to a really smart gauge that does everything you're doing now and a whole lot more. So definitely an option that's out there. And so the TEC does control your the DM32 does control your TEC fans. It's actually built into the gauge automatically. You can see there's an adapter that you use just below it that converts the signal, similar to the you may use that for the DG700 to do their auto testing in terms of pressure. So similar concept, but the Retrotec always uses a standard set pressure or a set speed, and does that. So you don't really need to use a dial. You can use a dial, but in general, it's just a lot smarter, simpler, better interface that actually happens with the DM32 smart gauge. Okay, so this is my trigger to record. So we are recording. So we record this. It takes us about maybe a week, sometimes two, to get this up and listed. I will create a PDF that will be sent out to everybody, so you can actually have this as a PDF. I'll try and separate some of the animations so that it makes sense as a PDF. So again, thanks everybody for being here. Let's kick this in. So if you're wondering what I look like, that I am not Gary Klein. For those of you who know Gary Klein is, he's the guru of water usage and conservation. But I'm mostly focused on BPI, ResNet. I'm an ICC certified, and these are just kind of my background. So if you want to reach out, you can clearly do that. And if you want to stay informed, like you didn't know how you got a hold of this information, you can do one of two things. You can join the Retrotech newsletter, which is on the main page. And also there's a Retrotech blog that kind of gives some information about what Retrotech is doing and what's new. If you're a residential person, you want to be tuned into our cloud. I can predict that our cloud, which is a automatic testing process and geolocation app, will be, it's our goal to integrate that into commercial duct testing next year. So it's our goal to come up with a SMACNA test for our cloud, and that'll be a major feature and a coup in terms of what people are doing in the field and how to make sure they do it automatically and correctly. One of the things that Retrotech has done, and that is this is one of the things that Cullen Ginge was fundamental on, and that is supporting the industry. So if you are doing something that's on this list, I encourage you to reach out to Retrotech on their main site and do a follow-up. They're going to ask you some information about your website and what kind of stuff you do. We actually go to the website and vet you and who you are, and that you can say, yes, I do these things. So if this is something you do and you use your Retrotech equipment, then you could be listed on our site. So some of these services are sometimes hard to find, just through a Google search. So some people realize that we're one of the Google searches that shows up for these people. And it's a great way to promote your services and show a region of where you're at. So if you're looking for that, Retrotech is there to support you. I thought I would use this slide to explain how Retrotech, who's been doing residential duct testers for, I don't know, almost 30 years or something, ended up with a commercial product. It's been out for about 4 years, I think. So the owner and founder, Cullen Ginge, went to another manufacturer and said, hey, we've got an amazing smart gauge. Would you like to use our smart gauge with your existing commercial duct tester? And they were like, nah, we're okay. Thank you, though. So he says, okay, and hung up and decided that he was going to make his own commercial duct tester that was smarter, better, lightweight, and cheaper. And actually did more flow and more power than what theirs did already. So he was like, I'm going to beat you at your own game. Honestly, this is my opinion, and it's pretty common that most of the commercial duct testers that are on the market today are still following a 1960s, 70s concept of throw a bunch of air into something, use a calibrated orifice, use that orifice to calculate what your results are, and then determine what your leakage is. And it's a very cumbersome concept. There are some major advances in how that cumbersome technique is being automated, but in general, it still is a heavy, cumbersome device that still uses this orifice, and you still need to go to another place and confirm what your results are. So this is actually, I say it's changed forever, because now you actually can get a duct tester that one guy can carry around. You don't need two people. And he can go up to the 5th floor if needed, because there's no skip or there's a bunch of rickety stairs, and go up and test some of the duct systems and carry that to the next area that he needs to test. So this is actually going to be a major saver in terms of not just labor, but also potential injuries or other challenges where you got to drag something up a couple flights of stairs. So the Retrotech has been known to make sure you get a complete system. You get everything you need to do the most common tests that you would do for your system. So you get a custom deluxe tool case. You get the DM32. Now this is a different gauge. So for those of you that have a residential DM32 smart gauge, this is slightly different, because this actually has a different sensor that goes up to 20 inches of a water column. So the ones that you have now can go up to around 5. The newer ones may do 10. But in general, the residential one will not work on a commercial fan. So you cannot just get a fan and use your residential gauge. As well as we're not really fond of you using the 20-inch gauge on a residential system because it really just isn't focused and calibrated for the range of results that you're trying to do. So in general, this gauge, the DM32 20-inch, is designed for the commercial systems that Retrotech sells. But you get a variety of ranges, so you don't have to buy them individually. You get the flex, you get a 30-day trial of the software, all the stuff you need in a nice case. So it's a nice system that's easily transported. Everything that fits in the deluxe tool case is only 35 pounds. So you can actually, some people get this so they can actually take it on a plane. When I travel to a show, I can use it as checked luggage. But the fan itself only weighs 20 pounds. And again, as I mentioned, you get these 4 ranges automatically. So there are ranges that go down below 18. They go down to actually 1 millimeter. So if you do need to test incredibly super tight installations, it can be done with this device itself. It includes a variety of amazing quick guides, which I gave you as part of your downloads. I gave you this, the one on the left. It kind of goes through step by step as to what to do and how to use that. If you have a commercial duct tester from Retrotech, please read the quick guide, because I've gone out to do a lot of training for a lot of folks and they just never read the quick guide, and they just turn it on and it goes crazy because they weren't following the basic instructions that are included. So please read the quick guide. And there's a variety of other quick guides on how to use the gauge and other support. So our philosophy is ditch the weight. Whole system's only 35 pounds. And this is the kind of stuff that I see on the field. Is this is a normal kind of system that's out there. Next thing you know, I show up and I have this secondary option of, one guy can carry this around and do all the same tests that they could do with that big device, and actually more accurately is really the reality. So this is actually where we're headed. And here's one of the things I went to. I go to UGA frequently with a buddy to do some testing and playing around, seeing the system. I don't get out much, so in order to use this, so they allow me to come down whenever they have a system that's able to be tested. So there's UGA work that's being done here in Atlanta, or I go down to their other campus. And so one of the challenges was they were interested in buying this, so they handed it to one of their technicians, low guy on the totem pole, and says if he can walk over to the building behind you and get to the 3rd floor, as it is, without much of a challenge, then they definitely were interested. And it wasn't as though you could go up to the direct steps. You had to go over and walk through, as if you've been on a commercial site, all of the rough areas where people pull in. It's incredibly muddy, not user friendly for somebody to walk on, let alone try and drag a cart. And then go up to the 2nd floor, which is our direct entry, on a locally made wooden ladder. I wish I'd taken a picture of that ladder. It was a little shaky, but he was able to go right up with it. Wasn't an issue. And from there, he can go up the internal stairs and get to the 3rd floor. So that's what's changing about how people are able to be much more user-friendly about how they're able to test various installations while the site is being under construction. I have a lot of simple testimonials on here. You can go online to see some of them. The one in green is somebody who actually was somebody who was involved in NEB. In fact, he was the president of NEB for a while, found this to be an amazing device, and got another couple of units. In fact, whenever I go to show this to people live, they're like, I'm debating about it, and they end up buying more than one right there on the site. The guy on the left here he's in California and goes to Hawaii, and met me at a show and said, please let me buy your system, because I'm going to Hawaii at the end of the show, and right now I'm taking my huge device apart, so everything weighs less than 50 pounds. So I can travel with it. And he still is paying additional fees because he's got 3 different suitcases full of his duct tester. And mine, he was able to do checked luggage. So I asked him to do me a favor, show me a test he was doing in Hawaii with a Hawaiian shirt, and he did that for me. So it's a great marketing tool. So everybody who has these swears by them. They love them. They could describe them as a major game changer for not just normal flows, but even really low flows. Is one of the things that's been beneficial. Let me give a quick comparison as to what we're trying to talk about, or some of the things you may have downloaded. So one of which is that you'll see some numbers, like you'll see the 441 or the 451. Okay, so the 441 is just the basic duct tester. It includes all the accessories. All the systems always include all the accessories, and they come with the standard 20-inch gauge. The 451 also includes the depressurization cone. So that's a big cone that actually fits right there on the front of the unit if you want to do depressurization. So if you're doing not just pressurization, but depressurization, definitely something you want to add to your purchase, right? The other thing you may see is this number 442 or 452, and the 2 means that your gauge is now Wi-Fi enabled, all right? All the gauges come with a chip that can be active later, and people are like, well, that's kind of cheap or cheesy, but some people want a second gauge, and they don't need to spend $300 on Wi-Fi that they don't need. But if you need it later, it can be activated. So we think it's a nice feature for the user who doesn't need Wi-Fi all the time. Let's save $300. All right, so you can get it. So if you're talking numbers, or if you're looking at numbers, this is what the number system means for Retrotech. All right, let's compare some other units that are out there compared to Retrotech. So, in general, we're going to look at some, the Oriflow systems or the Panda. They have a couple of different systems, but we tried to pick one that was similar in price, or actually even almost double in price to the Retrotech model. So clearly, we can move a lot of CFM at 8 inches of water column. So there are some that may do more, but in general, again, you're carrying the system up the steps, and most people can get away with a variety of tests with under 300 CFM. So it's a incredibly diverse and tool that does a lot of the testing that's required. So here's why this little thing. In fact, really, the reality is we just took the similar motor off of these 150-pound devices and got rid of all the extra stuff and souped up the motor. So this motor that's inside here, variable speed motor, does 10 times the RPMs that these other motors do. So that's why you can get 20 inches of water column out of this, and you can still get around 300 CFM at 8 inches. So it actually competes with the big boys and actually exceeds them. And it's just really the motor itself. And Retrotech follows a different pattern in terms of where and how they use their orifices. In fact, we call them plugs or ranges in our industry. So it's all the same language: orifice, range, or plug. And these are actually incredibly easy to change and very universal, right? So instead of actually using tools or wing nuts or something that takes multiple minutes to change out a different orifice, which you need to buy separately on the left, it already includes 4 ranges, and it's merely a matter of snapping them out and snapping them back in. So it's real simple to always make sure you can find the right range you need and change it in a matter of seconds. In fact, you can, depend on your test, you can do it on the fly and change it in the gauge. You always want to make sure you change the range in the gauge. That's one of the things that people forget about. Okay, so if you are going to do, so we're pressurizing here, so you can see that we've connected the flex duct to the side of the unit. That's the most common way that this is done. All right, so we're pressurizing a duct system here. I'm up in Detroit working with some folks. And but if you're going to depressurize, then you need this additional cone. This is the 450 unit, right? So we added this to it. It can be added as an accessory by itself, or purchased later in time. So let's talk about the gauge itself, the brains that are behind what you're actually doing. So many things out there may be a magnehelic manometer. They may be digital, but these are really not the most accurate devices. In fact, these have actually been no longer allowed to be used for NEB people because they just don't fit the accuracy that's required for these. So, and we're talking about full scale, which means that the entire thing does 10 inches of water column, and it's 1% accurate. So if you start applying that to your actual results, I'm going to show you how inaccurate or how much of a variance you might have if you're using some type of magnehelic gauge, right? So for the Retrotech and actually, Energy Conservatory, make sure we're on the same page. It's 1% for all readings. All right. And in fact, it's even a little lower, but it was easy just to keep these kind of numbers here for as an example. All right. So we actually have results that look like. Oh, the other thing is you have to do is make sure your magnehelic is always leveled. All right, it has to be level, and then you must zero it every time you use it. So every time you move it around, you got to make sure it's level, and you got to make sure it's zeroed each time. So there's a little screwdriver that goes in with that. So here's an example of what happens if you use a magnehelic. That's 1% of full scale versus 1% of reading, okay? So you can see over on the left that if you're doing something that's even 4 inches of water column, you could be off by 8%, right? And if you're doing something that'd be more of a low flow type of a test at 0.4 inches, you could be off by 40%. That means your numbers are really just kind of shooting the dice right there. But you can see the difference between actually a digital manometer that has amazing accuracy is that everything is 1% no matter where it is. So you can see that I'm off by 0.1 inch, I'm off by 0.004 inches. To the lower you go, it actually becomes really more accurate as it is. So this is why you should be looking for something that gives you accurate readings consistently all across whatever type of test you're doing. And remember this 8% or 40%, because there's actually a certain amount of range that you must be testing or in order to get to your results. So if you're already wondering if you're at the right test pressure and to get your results, and if your results are that critical and you realize that you could be off by 8%, that can be a significant number, especially when you're dealing with some really requirements that are incredibly tight ducts. So it's your goal to make sure you can get the most dead accurate results in order to maintain super tight systems. I mentioned this earlier, so we got to manually zero the gauge, make sure it's leveled. When I read through the manuals to do how to do these commercial systems with these other manufacturers, I was blown away by just how complicated they were, and that we're in the 21st century. So it was a kind of a cumbersome concept of zeroing the gauge, perform the test. Once you look up that test, then you got to go to your actual orifice that you actually had calibrated, those metal ring plates. Each one of those actually has its own calibration listing. So then once I get my results, then I got to convert that from this orifice itself. It has its own documents that come with the manufacturer. So you can't lose those because you can't change them around. So whatever orifice you're using, you need to make sure that it actually has the calibration information with it, so you can determine what your real results are, and then divide by the flow area. Or again, we're just dealing with establish a test pressure by hitting set speed. I can read the results directly in the gauge, and there's some amazing software that does this automatically for you. It finds the gauge, and you just hit go for the most part. A couple other methods you can use to control it. So one of which is that people use a sliding gate, which actually is the original concept for the original blower door. So if you weren't familiar with the, blower doors and they first were used, it actually was a fan and you were sliding the gate. You weren't really using rings or ranges. You actually had done this process of how far over you move the gate. Some of them now have more of an advanced control knobs or a little more sophisticated controls. They're finally coming of age. And the smart gauge has got a few options on you. So there is actually a speed control knob that's on the unit itself. So the commercial duct tester and all of the fans that Retrotec makes always has this backup speed control knob that you can actually use. So for some reason your umbilical, which has all of your connections to the gauge, for some reason is damaged, you can still use the tubes and actually control the speed of the fan manually. So that's always able to be done. Or you can actually do everything directly in the gauge itself, all right, by just hitting set speed. And the other option you have is you can actually use some apps that actually allow you to control the gauge remotely if for some reason you need to put your duct tester up on a scissors lift or something to get it closer to the duct system itself. All right, I'm going to pause for just a quick second, and I'll let this run through. You can kind of see this. I'm checking for some of the questions that are out there. So as it goes, I'm trying to show the difference between what's residential on the left, the test pressures that we normally test in, and what commercial people test in. So you can see if you're a residential guy, the kind of pressures that you would be using in order to comply with some of the commercial stuff. So someone asked if there are video and trainings. Most of the stuff we have right now is through YouTube, the kind of stuff you have right now. We are hoping to complete some trainings in 2018 that actually take you through this. But if you follow some of the things that I'll be mentioning here in this webinar, will give you a pretty good fundamental understanding about how SMACNA works and how this actually goes down. So some of you are asking about some of the things in the background. So I want to have some of the direct sales people or support people get back to you about the trade-ins and other stuff that's on there. So someone asked about his podcast, and his podcast is HVACR with R, not just HVAC, HVACR School for Michael Orr's. You can do Michael Orr's HVACR School in Google, and it'll actually help you find his podcast. Someone asked, is there a commercial, is there a certification? There is one for residential. We do have if you buy a system, you can actually get online training through Retrotech that actually provides certification that some states actually accept as in terms of being able to do duct testing. Louisiana is one of them. So, but if you do get a residential system, then you can actually get some online training that support what it is you're need to know about the system and how it works for Retrotech. So back to our webinar here, and you can see that some of the test pressures are actually pretty huge if you're a residential person. But for people who live in commercial, they just talk inches of water column. So it's just a different language, but it's a much greater test pressure that they actually use for operation and in their testing. So Eric asked about how much for the software. I'm going to get to software in a few minutes, Eric, but make sure you remind me of your question if I didn't answer it when I come to it. All right. Okay, so we're going to talk through about the differences. Here's the most fundamental difference. Okay, so I talked to several people that are residential people, and they go and they say, "Oh yeah, I do commercial duct testing." I'm like, "Oh, what kind of commercial duct tester do you have?" And like, "I don't have one." And I'm like, "Oh, and what kind of compliance are you doing?" They're like, "Well, I just follow the residential guidelines. It's just a duct system." And the rule of thumb is if it's a approximately 5 ton unit or less, you can do that. All right. But if you see some of the test pressures that commercial people are doing, you'll realize that your residential unit can never reach those, number one. And you're testing stuff that's really considered non-compliant in terms of commercial concepts. Okay. So residential, we test the entire system all at once. So we test the supply, the return, the air handler, the boots, the branches, everything, one shot, one test. How much are you leaking? That's not the case with commercial. Some of this is dictated by SMACNA or your standard or the engineer, but in general, you only are doing the duct run. In fact, it's mostly only the main trunk that you're testing. Most of the branches are capped off and are not part of the test. Okay, and typically because some of these are such long, huge, massive runs or shafts are moving up through the building, these are all kind of isolated or separated. So you're typically doing sections of the duct, not the entire system all at once by any means. And you test supply and return separately. You do not include the air handler or branch runs, or you do not include anything that's part of the VAV valves or what would be considered like the boots or the final output or input from the units themselves. So the VAV is actually the variable speed, which you can think of this as like a reconditioning unit. It may be heating or cooling the air one more time just before it goes into the area that it's provided, it's serving. So again, we're mostly just testing main trunks. That's it. Okay, so compare that to residential. It's a completely different animal, not necessarily something that's easily comparable or done from one to the other. So here's some things that are also quite different between the residential and commercial. All right. So if you're dealing with low pressure is less than 2 inches of water column. All right. There are some standards that are out there for commercial. All right. Most of the systems and requirements say nobody needs to test it. It's less than 2. It's not, it's people are like it's low flow. There's less leakage. Nobody cares about it, which is kind of sad. But the design engineer or SMACNA can say, yes, you still can, and here's how you do that. The design engineer is really the code and standard for commercial, right? It's a totally different world between what we do in residential when we're following the IECC, whatever year you want to put behind it or whatever amendments your area's got, versus what the engineer says to do. Whatever the engineer says to do, that is your compliance path. So he may say, I want this much leakage, or I want to be this kind of leakage factor or leakage class, and you follow the SMACNA guidelines, or he'll tell you he just wants a certain percentage of leakage. We'll go through each one of those. Now, if you're going to deal with the gray area of 3 inches, all right, and higher, then we're usually required to be testing. In fact, the code actually says above, equal to 3 and above, we're going to be doing some testing. And there's a variety of examples that are in ASHRAE, ICC, and SMACNA that all explain the compliance path. ICC and ASHRAE all come back to a SMACNA compliance pathway. So SMACNA is really the governing body about how to do the test. Your results are determined by your engineer. All right. So there's one thing is how to do the test. It's another to say if I'm passing or failing, which is your engineer determining what he designed for this system and is it working. All right. So let's go through some compliance and make sure we got this on the same path. So if you can see by the illustration that's kind of on here, it's pretty old school type of a concept. In fact, what it looks like and what some people actually do use is a leaf blower. All right, so a leaf blower will create an enormous amount of pressure for you, and then between the leaf blower and your flex duct, there's an orifice. Again, back to this calibrated orifice. So if I know how much flow is going through the orifice with my leaf blower, then I can actually determine what kind of leakage it is. Okay, so it is a very loud and homemade kind of a concept. In fact, many of the people I meet out there are like, "Oh yeah, we just made our own. We got this and we got this. We took this off of this part. We got it. We got our own motor." And the one thing they always say is, and then we got our orifices calibrated through McGill or through somebody that actually does that. So that's a common theme that's out there. So, but most of the people that make their own, they still are monsters. All right, they look like a car engine that they took out and put on wheels and wanted to tow it around to do these kind of tests. So it can be done. Anything can be done. Okay, so in the next few slides here, we are going to define how to do a test and why you do a test and what are the ways to do the test. This one little chart, and if anybody's read the SMACNA manual, I tried. It was a difficult read. I've read a lot of code of books and standards, and of all of them, including the hash rate stuff, this was actually pretty challenging read. But when you get to this one simple table, it tells you everything you need to know. Okay, so we're going to go through how to use this table. I kind of color coded it so we can all follow along and make sure that it's all on the same path. Okay, so the first thing you need to figure out is what is your construction duct construction class, and that actually is provided by the engineer. The engineer says, here's the system, and this is the construction class. So this is what's going to operate at, and they can tell you what they want to test it at. So sometimes they may say, it's going to be a 4-inch, but I want you to test it at 6, just to make sure that it will handle the pressures that could exceed that at any point. Okay, so there's a test pressure and a design construction class. Okay. Once I know that and know that, let's go back to here. Let's work our way over from the left. So we've got a seal class, which is determined by how much pressure is going to be in the ducts. So if you look at seal class C, which is just black and white, you can see that I got 1/2 inch, 1 and 2 inches of water column, and it has minimal requirements for the sealing. So the next line down is sealing that's applicable. It's just transverse joints. Okay. So seal class C is what I actually physically have to seal. All right. And let's move over to the 3-inch. 3-inch is its own kind of category by itself. So that all of my transverse and longitude seams from now on need to be sealed above 3 inches. And also we need to do duct and wall penetrations once I get to seal class A. Right. The majority of things that most people do are in this concept of seal class A. You need to seal, your longitudinal seams, transverse, and wall penetrations, all in this category. All right. You really should be sealing them all the time, even though it's low pressure. You really should be sealing everything. So, and this includes spiral ducts also, in terms of all of those joints really should be sealed because that's part of your longitudinal seam, and they do leak. They may not look like it, but they actually do have leakage. And now below, if you follow these columns down, okay, so let's going to follow column A down because that's our most common construction class and test class that we're going to do. So there is then they decide what kind of ducts are you using. It's either metal or round, and that determines your factor, the leakage class that we're actually going to apply to this. Okay, so we figured out that we're going to be in the seal class A, so we now know what to seal. And just for our example, we're just going to say everything is a rectangular duct. I know it's not. There's always the branches are always round, blah blah blah. But for just a simple example, everything is a metal. So I now understand what my multipliers are. Okay. So once I know that, we're going to say that we are going to be a construction class 6, and we're going to test at 6. So we're going to be putting 6 inches in and testing at that same pressure. So we're all on the same page. So now I actually have this formula that actually I'm going to go through how this actually works. So this is my leakage factor in the green, leakage class is in red, and this is the multiplier, which is the pressure times a factor of 0.65. Okay, so the pressure is 6 inches. So now suddenly I got some multipliers that are coming into play, and the leakage class, which is CL in red, is right there, is giving me at 4. So I follow this across. It says 4, so I now know it's 4 times 6 inches times 0.65, and that determines my leakage factor. All right. So there's a way to do this as the opposite. Let's say I need to go the opposite. There's my 4 times 6.5, and there's my answer. So I'm approximately 13 CFM per 100 square feet. We'll make sure we understand some of these details. All right, so here's our example. So they say that it's 6 inches at seal class A. It's metal, it's rectangular. My seal class is 4. And we are going to test one section that's 336 square feet. And that's actually all 4 sides, really 6 sides of the duct that we're going to test. So usually it's capped off on both ends. And there's all the 4 sides that are around that. So that's actually how you determine square footage. It isn't square footage of the area it serves, like residential. This is actually square footage of the actual ducts that we're testing. So I want to know all 6 sides, what's the square footage? So in order to determine the leakage factor, which is my allowable leakage, all right, which is the CFM per 100 square feet, it's a similar concept as residential, but it's square footage, again, of the ducts, all right? Or you can actually do leakage class, okay? So some may give you the leakage factor, not that common, and you can do the opposite and determine if you comply with a leakage class, saying you must be a leakage class 4, and then you can do a backwards calculation and figure this out. So if I know my leakage class, because I clearly know it's rectangular, and I know what the test is, then here's how the math plays out, okay? So leakage class, test pressure, these are common numbers that clearly show up because the leakage class is very common. Test pressure may be 6, 4, 8, 10, all those kind of numbers very commonly show up. And so again, my results are 13 CFM per 100 square feet of the duct surface. And if I want to convert that and I have 336 square feet, divided by my original factor, then I can determine what's my CFM that I'm allowed to leak total when I do that test. So I can either determine my CFM or the CFM per 100 square feet, both of which are very straightforward kind of concepts. It depends on what your compliance path is you're following. So this is the exact opposite. If I know my leakage factor, so I know my leakage factor is 13, or what it was 12.6 or something, then I can also determine my CFM to be 43. So that you're going to get the same numbers. It depends on what number you're looking for compliance. Okay, most people are looking for CFM per 100 square feet, so that's why I want to make sure I gave you both. There are different compliances between ASHRAE and ICC. So ICC is looking for the leakage class as their concept. All right. ASHRAE is looking for the leakage factor as part of their concept. All right. And some of this stuff is going to begin to change, I believe, in 2018 with some updated versions of all of these. All right. Before I go into the 1% of flow, I'll see if there's any other questions that we should address real quick. So Keith asked a great question: does the line duct make a difference in square footage of duct? It does not. I will reserve my comments about line ducts. All right. Curtis says that he's taking the blame for being an engineer and designing the systems. So I appreciate that, Curtis. So maybe next time I do this, I can include you. So if you send me some information, I'll try and follow up, and you can give some information on the background as to why and how you're designing some of these. And someone asked how to spell Brian Orr, and it is Bryanor. That's correct. Great. Okay, so the thing that's happening now in the industry more than the other is people are the engineer is saying, you got an 80,000 CFM air handler that's going to serve the whole building, and you can leak 1% of system flow. So system flow is 80,000 CFM. It's actually a rated, you don't have to measure it, it's a rated CFM. All right. So the challenge is that the engineer, I'll be blunt here, the engineer can sometimes design a leakage that is actually wasn't designed in the ducts themselves. So they say 1% of system flow, but that's actually not achievable. And I've worked with many of sites where people were like, it's just so tight that we really struggle to achieve a passing, and they got to go back to the engineer to be like, look, everything is like covered in mastic. All right. The only place where we're leaking is in some fractions of strange connections, or probably at the air handler or some other place where they can't actually account for it. Okay. So again, we're going to test each one of these trunks by themselves in these runs, but they struggle to get down to 1%. I'll show you kind of why or what some of the challenges are. The one thing I need to know is what's the job total duct? How much square footage of duct is going to be installed in the entire installation for this air handler. If you don't know that, then you can't actually do this 1% type of compliance, all right? So whoever engineers it and then determines exactly what is going to be installed needs to calculate the total ducts, all right? And once I have that, I can do some simple math as to determine, well, I can leak so much CFM per square foot based upon the total ducts that I'm installing. So I'm allowed 0.084 CFM per square foot. All right. So that's a really super tight system. All right. So let's go through some of the ways this will play out. So if I'm going to just test one section on the second floor, section A, I can say it's 1,200 square feet, and I know what my CFM is that I need to pass. And so I did my max leakage, and it was at 0.84. So I actually am below that. So my results were 98. So I'm less than my max that I'm allowed. So it's 100.8. The challenge is that if you're going to do this, every area that you test as these little segments, they all must pass in order to really to do it correctly and not actually cause a nightmare for yourself. Don't think that you can add up this section. It maybe it fails by 5 CFM, and then you hope that you can recover that on the next run. It really becomes a challenge. So the goal is just everything passes, and then you can say that I tested each one of these sections and they all passed. But to try and do them and add them up as a total in terms of the CFM you've got, and then say that yes, everything passes, I encourage you to avoid that as your process. It can just be a nightmare. Because if you fail in the end, you're going to be struggling. So your goal is to just make everything tight and pass as you go throughout the building. One of the things you must know, again, is the total square footage in order to do this type of compliance. This is one that I wasn't aware of when I first started doing these presentations. So when I was working with the engineer at Retrotech about the software and how to update that and make it more user-friendly, I realized that I was doing tests in my house. I have a little rig that I use in order to simulate. Commonly, I'll do 4 or 6 inches of test pressure. And on the software, it says that I was not compliant. It didn't say I'd failed. It says you are not compliant. And I'm like, why am I not compliant? So according to SMACNA, you're allowed 5% below your test pressure and 1% above your test pressure, which I do know a lot of people in the field were not aware of that. They just try to get near this number. And when you're testing this kind of stuff, it's not as though the gauge just like sits tight and hums. It's like I'm not like, oh yeah, I'm at 4, especially inches of water column. This thing's jumping around like crazy. So there's some things that the smart gauge does to help with that. But you do need to know that these are the minimums that you must reach for a test pressure in order to be fully compliant. You can determine if you pass or fail, but if you want to make sure that you're fully compliant, then you must reach these kind of test pressures. Okay, most people do not. Most people get close to it and they can extrapolate. So extrapolation is either a calculation or built into the smart gauge. We're going to come to that here in just a second. So if anything, you want to be slightly below your test pressure because it doesn't take much to go over. And if you're going to use the software, you want to make sure you stay slightly below your test pressure in order to make sure that everything shows as compliant. All right, let me back up. One of the challenges that happens is that people will do a test, and let's say they're trying to get to 6 inches and they can only get to 4 inches of water column. The system, you're maxed out. One of the things I can tell the installer or the engineer is that we're failing. So a lot of times the people will test their own systems. Sometimes the tester is independent of the installer. So if I go to test something for somebody and they're like, well, you didn't get to 6. I'm like, well, I can extrapolate at 4 and tell you that you're still failing. I can go get another fan and add more pressure to it, but you're still going to fail, right? So I can determine if you're going to fail your test, even if I don't reach a certain pressure that's required for the test. I can still determine pass or fail. And the one thing you can always determine is that you're failing. I can bring 5 more fans in here because your system is so leaky that I need 5 fans, and I can tell you failed. But the reality is I can tell you with 1 fan that you're failing, right? So that's one of the things that is key in terms of doing testing. You don't need more fans just to confirm that you're failing. More fans will not help you pass. They will just allow you to get to a higher pressure. Again, you still failed. So the gauge, I'm going to go through that as to why the gauge can tell you with almost any kind of pressure that you get and how leaky it is. The end could be almost be off on one of your ducts, and I can obviously tell you're failing. but tell you where you would have been if we had reached your test pressure that we had to get to. So Maggie asked another great question. So she says, well, how are you doing the sectionings, or who determines that? A lot of times it's really just guys are in the field just understand this is about that we normally test this amount of duct work, and they just cap it off. Sometimes they'll actually put on an artificial, sheet metal cap, and all of the trunks are usually just covered with what we describe as duct seal. It's just a sticky plastic that usually goes off all the ends of the trunks. You probably could use this on the end, but you probably need some additional tape to hold it in place because of the amount of pressures that you're dealing with. But in general, most of all the trunks are just kind of temporarily sealed off, but the other ends may actually have what would look like a permanent end on it, but just gets taken off when they start connecting all of the pieces back together. Okay, so let's start with the smart gauge. One of the things that we call it a smart gauge is because it's incredibly intuitive and it's designed to help you. Okay, so one of the things that is awesome is that when you turn the gauge on, it goes right back to where you left it. So when you turned it off, turn it back on, it says, okay, last time you used this gauge, you were doing a commercial duct test, or you're using a commercial duct tester, and this was the range you had, and your inches of water column, your results were CFM, all that's on the left. I don't need to go in and redo everything. I don't need to pick a new device or a mode or a bunch of stuff. It's already there, ready to go. But I know that I probably need a more flow, so I'm going to change the range. So all I do is tap on the image on the left, tap on the image, up comes a new screen. I pick the new range or the new orifice and select that, and it goes back to the home screen, and I'm ready to now test. Right. So it's a real simple method to look and see what's on the actual fan itself, and visually change that on the gauge itself. So it's real, very intuitive and user friendly for technicians. One of the things that I focus on is that can I train a technician in really less than an hour on how to use this? And usually it takes even half of that once they understand what they're looking for, and that they don't need to redo a bunch of stuff into the gauge every time they turn it on. It's like, okay, I just need to make sure that the range that's on the device is the range that's on the gauge, and I'm ready to begin. So when I tell people to turn on, I ask them to confirm a few of these settings. Some people put a sticker on the side, just says that the top is on inches of water column. I always start at the bottom on CFM. Some people start on CFM per 100 square feet, but our goal is to get both of those out of this test, and it's easy to do. I confirm that I've got the right device, and the orifice is on the bottom, right? So all that's very straightforward. And here's how you do a test. It's not that complicated. We're going to tap set speed. Do not use set pressure. Again, one more time. Set speed for commercial duct testing. Okay, so I tap set speed. All right. And I usually start with 1%. Maybe I'll start with 2. And then it's going to kick in. You're going to watch the flow go up, and it's going to be reaching that. So I can actually do the up and down arrows now. All right, I'm now increasing the speed of the fan till I get to my test pressure. Okay, and again, I want to be near 4, not very far over 4. Maybe I'd be at 3.8, and can get my results. All right. So I'm going to explain what the add feature is, because the add feature can extrapolate my results if I didn't get to my test pressure. Right. But in general, it's simple as saying, set speed, increase the speed in the fan until I get to the pressure that I'm trying to test, and get my results right then and there, CFM or CFM per 100 square feet. So let's talk about this extrapolation, or the add feature that's built into the gauges. All right. So on the left, I'm trying to get to 4 inches, and I'm just shy of meeting my minimum. In fact, if you rounded this off, you technically got to your 3.6. All right. So, but I didn't get there. But I want to know what it would be if I was actually at 4, or what would my test pressure be? Maybe this is actually, I'm only at 2. So it works the same manner. All right. So you can see that on the bottom here, I've only got 94.06 CFM. But I want to know what would it be if I actually had gotten to 4. All right. So I turn on the add feature, which is in the upper left-hand corner. It's a little at symbol that we use in our emails. And on the left, it's off. And on the right, I turned it on. And now you can see the difference between 94 to 101 CFM. So technically at 4 inches, I actually have 101 CFM as my actual flow. On the left, it could have been 2 inches of water column that I only had reached. And clearly I was not in total compliance, but I could determine that, yes, you're still going to pass once we get up to that higher test pressure. One of the difference that, again, as I mentioned a few times, is that when we talk about area, it's actually the surface of the ducts, all 6 sides of the ducts. Somehow I lost my right side of my end over there, but it's all the sides of the duct. This is your surface area that you're calculating. And there's a variety of little tools that help you do this in terms of rectangular or especially round has its own calculation challenges that go out there. So let's go right back one more time so we can actually say that I can also tell the gauge, instead of giving me CFM, I can say, well, give me CFM per 100 square feet, and I can determine what my that is that I'm trying to comply. So if you look in the bottom of the gauge here, it's actually telling me that I have an area of 458 square feet that I'm actually testing for my CFM per 100 square feet, and I entered this into the gauge itself. So again, if I didn't reach my test pressure, I can still determine if I'm passing or failing with my add feature at CFM per 100 square feet. So the difference between 20.5 or 22.1 is the difference to determine whether or not I'm complying, or I would comply if I had to have more pressure added to this to confirm that it was structurally integrated. Okay, I got a few apps and software that actually can make your life a whole lot easier. So someone asked, will the DM32 do the door fan test? And it does, but this one is not the one to use. As I mentioned earlier, that this one is a 20-inch gauge, and it's really designed to only work with a 20-inch duct tester. All right. So let me go back 1 second. Just go back. And it only is really designed to work with the 20-inch commercial duct tester. There are gauges that are totally universal. So if you got one for a blower door, it clearly does residential duct testing and a variety of other stuff that's built into the gauge. But in general, you really this currently right now, this device, this DM3220, what we kind of refer to it as, is only designed to do commercial duct testing. Someone asked, do I set the gauge first to 4 inches doing set pressure? Okay, so let's make sure we stress that. In fact, I'm going to add, do I do this again? Do not use set pressure. Okay, and the reason is that this is a huge amount of pressure that goes flying out of the fan and into your flex duct, and it actually begins to pulse because it's such an immediate amount of pressure that it struggles to maintain that pressure because we didn't start off at a slow and even consistency. So do not use set pressure for the commercial system. It's only set speed. Okay, so that's whenever people are like, oh, this thing doesn't work, it just jumps around, it's because they're using set pressure. So do not use set pressure. It's only set speed. It just allows you to get the fan to engage in lower pressures and build up to what you're headed without it overcompensating or over pressurizing the flex and the duct itself and the unit, so it ends up competing against itself and causes some vibration or gets the flex duct jumping around. So again, set speed is the only way to go for commercial duct testing. Any other questions? Someone says, how does the gauge know you want 4 inches? Okay, excellent question. So there is a setting that's in the gauge itself. I don't think I have those slides in here. Sometimes I hide slides just to kind of reduce my slides and things we talk about. Underneath the settings, so if you have a DM32, you can go to settings. And on the second page, it's got what's called an at pressure area. You can actually tap this area, and now that would determine, usually it's set for 50. If you use it for residential, and let's say you're going to do a blower door, and you say set pressure 50 pascals, or duct testing for residential, you do set pressure 25. When you turn on the add feature, it's automatically going to use whatever test pressure you entered. Okay, but commercial, we don't use set pressure, we use set speed. So when you turn on the add feature, it actually is going to go to the preset settings that are inside the gauge that say, oh, when you want me to activate this add feature, the determined preset is what you've actually gone into the settings and determined that. So if you're going to test at 6, then you would want to go into the settings and make that 6 inches of water column. The settings are also related to whatever type of unit I've got here on channel A. So if I'm using pascals, it also relates to pascals. So I'm using inches of water column, it shows up in inches of water column. So it's definitely a direct ratio as a test pressure, but you need to preset that in order to get that. So most people are commonly testing 1 or 2 pressures, but you do need to go into the settings and do that. Hopefully that answered your question. Someone asked, do all the DM32s have that? In fact, yes, all the DM32s have that feature in the upper left corner, whether you're doing residential or commercial. It's been there forever, and in fact, it's also built into the older, the DM2 units. So it also had that as a feature that's on there. So I don't have the exact round duct calculation. There's a variety of apps that you can actually grab and put on your phone, or stuff that's online to help you calculate that. How round is a duct? Because there's also, to make this, Eric's asking about how do I calculate the surface area of a round duct. There's also oval ducts. Okay, so this gets kind of like fuzzy and challenging. That there's definitely some additional math and apps that help you determine the surface area of a round or oval duct that's out there. Great questions, everybody. Yeah, Eric's asking to reach out. So if you do want some information, we review these kind of questions, but give me your, the best thing to do is be like, if you're looking for something specific, some more information, just kind of say, let me know what it is, and go and throw your email in there. Nobody else can see these except us, but it makes it really easy for us to follow up with you. So I'm looking for more information on whatever that might be, and give me your email, and we actually will be able to follow up with you. Somebody will either today or tomorrow for sure. All right, let's dig into some apps. I'm sorry we're running low on time. I didn't realize we were so late. So let's dig in here. So, but great questions and good information we've been able to follow. So real quick on the app. So Gauge Remote is one that we think of this as like a remote control for your TV. This is a remote control for your gauge. It works on Android or Apple. You can download this, and what it does is your gauge must be Wi-Fi, right? And then there's ways to get your gauge Wi-Fi to connect to your app, and then you're able to control that remotely. So again, if you had to put your duct tester up on a scissors lift or something to get it closer, then that's a great feature that's out there. We do have lots of other webinars that focus specifically on these types of apps, so I won't spend a lot of time on it directly. You can go to YouTube channel for Retrotech and hear my voice for days on end about a lot of the other options that are out there. Another one out there, this is actually a PC. The other one was actually a mobile app. This is a PC app that does something very similar. Some people actually use these in tandem. They may have two duct testers that they're doing to do a larger flow. That also can be done. You're going to read the two readings together. But this actually is a way to actually do this on a PC, do the same concept. I can actually read the gauge remotely. Here I'm able to do this with a USB or Ethernet connection or Wi-Fi. So there's some options to do this on your PC. So here's one of the concepts that goes out there. So Fantastic is actually the option that's out there that's automated software that does a SMACNA compliant reports for you, okay? So what it does is says you can enter the data manually, or you can auto capture it automatically, and you begin your test. It can ask you a few things about the class of the ductwork, the temperature, and the operating pressure of the ducts. Everything has been changed to inches of water column just recently. It gives you your phenomenal custom report. I gave you a custom report in your downloads for your handouts. So basically, it goes through the concept of give me some information about the building. It'll actually find your gauge. I do not recommend using Wi-Fi. Do not use Wi-Fi on here, only because Wi-Fi has a hard time giving you all the data that this app needs as rapidly as it needs it. So sometimes it may say waiting for the gauge, but using an Ethernet cord, you can use this for hundreds of feet, and it gives you instantaneous results. So it's the best way to go is to not have Wi-Fi as you're connecting for this. Even if it's right next to it, it's still Wi-Fi. We don't think of it as actually being intermittent gaps because our phones don't show us those gaps, but it does have those. What's my construction class and seal class? Some temperature, some elevation, some basic stuff that goes along with this. And now I can begin. It'll capture it. It tells me what my fan speed is, and I can collect each one of these as an individual test. And I can maybe do multiple sections. Each one tells me if I complied. But if I do 2 or 3 tests, one after the other, my report will show me that all 3 of them passed, or if one of them failed. So it's a great way to determine a variety of tests you're doing. Some people just do one test, hit a report, and move on to the next one. But you can actually, if you're going to do like a one long trunk for the second floor, I could do 3 tests that are all considered the second floor and say, the second floor complied, all 3 tests passed, or 1 test failed, and that's included in your report. So there's a lot of opportunities on how to give a nice simple report that's out there. If you are using Fantastic and you want to help us help develop these reports, please give us some more information on what you're looking for. We are trying to come up with some custom templates. I got a few last slides, and then I'll let you guys go. So I appreciate anybody who's hanging out a little bit of overtime. Last time I did this, I ended 10 minutes early. A couple of quick accessories that are out there. So there's a smoke generator. Again, if you're looking for more information, it's on the website, or we can send you something. This actually is designed to fill the ducts with smoke, and there's even an adapter that works specifically for the commercial duct testers. Make sure we're on the same page. Do not use this as it's shown in the picture with your residential. Not intended to be used with residential duct systems. But it can be used with commercial, only because the commercial moves this smoke through so fast that it doesn't really leave a residual that's actually an issue for these type of units. So no residential, yes on commercial. And the other one is a newer product. Is a very handheld, very small unit that allows you to find the leaks on the outside, or allows you to go around and see if there's leaks coming out of some other place. Can be used for air leakage or walls, blower doors, a variety of stuff. This is going to replace the titanium tetrachloride that some people use, which is just a very hazardous chemical that's out there. So Retrotec no longer sells titanium tetrachloride. So if you're using it, I highly encourage you to rethink this. At one time, people accepted some of the risks. Now it's considered very hazardous that's out there. I'm going to skip my additional opportunities. I'll add those in the printout that I'll do, and I'm just going to skip ahead to the end here, and we'll call it a day. This is in many of my other webinars that's been out there. So I'll answer some questions for those of you that are still around. Everything is made in America. It's made in Washington State, up in Everson, near the northern border. But it is actually manufactured and assembled all in the USA. So some people thought they were a Canadian company, but I can assure you that they are all assembled here in the US. I don't do enough work to somebody asks how much do you charge, and I don't do enough to actually make that determination. And I haven't really talked to most of the people that I work with. Eric's asking this question. They usually install and test their own systems. So it's not that common that you may find a third party person to do that. Sometimes smaller commercial systems are looking for somebody to come test it, or if you're determining you want to help somebody with how leaky their system is to make it tighter. I don't really have a feel for what that is on how much that would cost. Any last questions? A scissors lift, Eric asked, is a scissors lift needed? It's only needed if you don't want to get additional flex duct or that does that. Most of the tubing you have is plenty long enough, or you can get additional tubing. That's an easy thing to do. So sometimes you actually will move the unit up closer. But if not, you'd have to just get a longer flex duct to go up to the unit. So it's your choice as to how you want to set that up. As you can imagine, some of the time these things are like 40, maybe 60 feet up in the air. And sometimes it's easier just to get on a scissors lift and go up and do that with an extension cord to make that kind of a test. Someone asked, what's the most common test that's out there? Test pressure, I think it was. Someone asked, when would you depressurize? It depends on what the engineer is requiring. Sometimes people will depressurize smaller systems, like maybe for an exhaust system. That's one of the things I've gotten from people in the field. So Andrew, give me your email and I'll follow up with the cost of the system. I try not to do that stuff out on a webinar, although these are indirect sales things. My goal isn't really trying to sell them, so we try and follow up with people directly about the prices and everything. Is there a maximum tubing? Not that I'm aware of. The only thing you want to be concerned about is that it's not going to be sagging. It doesn't restrict your flow. And you probably have to, if you're going to do something that's 20, 30, 40 feet, you're definitely going to have to support that at some point, and then run that into your duct. So it's not going to be a matter of just plug it into your duct and let it dangle for 40, 50 feet. You're definitely going to have some type of support at the top that's not crimping it, and then let that flow down. There's no maximum about tubing. Tubing is a pressure element, so you could do. There is a slight delay that happens when you get to like 1,000 feet of tubing. All right, but in general, if you're going to do all the way across most of the warehouses or something like that, that kind of tubing is a minimal impact upon your test. I appreciate everybody who was here. I hang around for a few more minutes. If anybody else got any questions, I'll try and do that. If you need to go, I totally understand. Hope you had a great Thanksgiving. Happy holidays, Merry Christmas, Hanukkah, whatever it is you believe in. I'm hope you have a safe one and a great one. We will have some more webinars coming up here in December that are mostly focused on some of the most technical challenges that people call in about. We want to help you avoid those prior to them happening to you. So we're going to do a two-part series on the most challenging issues that people are calling in with our technical support. So if you do own Retrotec equipment, please come back and help us and learn more about that too. You can avoid them also in your life. So thanks, everybody. Eric asked, is there going to be ICC required testing in 2018? There actually is required testing already that's in compliance for commercial. The reality is it's just not that enforced. All right. Most of the things that commercial, Eric's asking is there ICC requirement that'll be in 2018 for commercial, and it's actually been around for quite a while. It's just not heavily enforced. The people that are doing these commercial buildings, it's not their main focus when they show up at the building. There's so many other potential issues and risks that whether or not they got their duct test done or showed their compliance isn't a high priority for some of these people doing the inspections, but it has been for a while. Usually it's depending on what you pass and get paid based upon what your engineer required you to complete. Eric asked a heavy-duty question on how to test an economizer system. All right, so I try to not exceed my knowledge level, and I'm quick to state that I don't know, to be honest. So that would actually be a much more advanced kind of question. I'd have to go to some of the people in the field that's out there. You may want to send that out to Brian Orr and his group because they do his actually on Facebook and on his website. And if he doesn't know, I'm sure he knows somebody that does know. So that'd be a great question to let's reach out to Brian Orr about that. And maybe we can get some, do a podcast on that if he hasn't done one already on how to actually test and determine how efficient your economizer is and is it bringing in enough fresh air. So for those who don't understand what economizer is, who are still on the call, an economizer is a commercial concept that determines how much you need to have makeup air for the occupants. I don't call it fresh air because it's not necessarily fresh, but people think of it as the fresh air. So it's air that comes into your HVAC system that comes from outside. It's usually filtered. They try and control where it comes from, but you can actually use that as a conditioning element. So for us, our residential concept is we heat and cool all of our air without using the outside temperature. So the economizer is this concept that I can use this outside air to temper the air that I provide for the occupant. So it can be used year round in order to maintain a certain temperature and provide the air that people need for their living conditions. So it's a great concept. How that's measured or how that actually gets sized is beyond me, Eric. So hopefully that answered your question just enough to tell you where to go. All right. Again, everybody have a great day. I will look for our newsletter, or you can go online to support under webinars, and you can see what else we're doing. And we will be back next year with a whole series. If there's something else you're looking for, don't hesitate to send us an email, and we'll gladly put together a webinar that's kind of focused on those kind of concepts. So awesome, everybody. Take care.